in week 8, we're going to be learning a little bit about subqueries. And I know in the past we've covered subqueries quite a bit, so I thought we could just kind of go through the PowerPoint. And if there's any questions, then we can do a couple demos. But I believe when we covered functions like the in and any, we covered quite a bit of subqueries, and you've seen me write them in a lot of examples. And we're actually going to be writing some subqueries for the final project example today. So I figured, we'll just kind of start with the PowerPoint and questions. If something comes up, just let me know. And if you want to see a demo, we can do that as well. But to start off, just what a subquery is, to basically kind of explain it is it's a way to kind of within a query pull some additional data. So there's a lot of times that we might want to have some of our own data from our database. But the difference is maybe we don't want to connect it with a join. Maybe it's kind of like this one-off thing, like where I don't want to add a column. I just want to filter on something, or I want to just pull this other value, something along those lines. So that's kind of what a subquery does. And it kind of makes sense. It's a query within another query, which is kind of what it talks about. Now, the one thing on this slide that I really like is if you're ever curious about what a subquery is doing, you can always run it by itself. And it'll tell you exactly what it's kicking out, so to speak. So for example, if we're getting the max customer ID from customers in this example, really it's just where the customer ID is 599. So it's not too crazy. There is one caveat to that, which we'll get to here in just a minute. All right, so a non-correlated subquery is when it can be executed by itself. So that's kind of what I was getting at, is meaning that you can run it by yourself and see exactly what it spits out. So when you hear or see non-correlated, I like to think about it like correlated means they're with each other, they're connected. So non-correlated obviously means that it's independent, meaning that I can just pull this at random. I can run this command by itself and it's just going to work. And that's a non-correlated subquery. So like in this example, if I want to select the country ID from country where the country is equal to India, I could just run that by itself, or in this case, I could run it in here. Now, the flip side of that is non-correlated subqueries. And correlated subqueries. Let's skip to where it's correlated. And that might be a typo. Oh, here it is. Okay, so correlated subqueries. What the correlated subqueries do is they actually connect the outer query to the inner query. So just using this as an example, you can see here that we're selecting first name and last name from customer. And we're doing this where clause. But you can see that we're selecting account from rental, and inside this subquery, we have a where clause that references this C alias, which is our customer alias. So the reason these are correlated or connected is because we're using a piece of the outside inside the subquery, which is really helpful, because a lot of times like you'll connect things and maybe you just want like for example, let's say we just want like to display a customer, like we do a video kind of rental store in the context of Sequila. Let's say we give them a platform where they can log in and kind of see some information. We could get their latest rented movie and display some information about it in something like this, but because we would maybe get some information about them to begin with, but we could also kind of embed this subquery in there to say get the max rental ID, and then we know that that's like the latest rental, where the customer ID is equal to the customer ID that we're looking at. All right, so throughout here, there's a couple of additional things like multi-column subqueries, which is actually where you pull more than one column. We've seen a lot of times where we pull a single column, but you can actually pull multiple columns. For example, like if you want to use an in to get like a list kind of a thing, you could pull a list instead of a single value. Multi-column returns cross columns. where you can actually kind of make like a key. So, you know, there's a couple of those. They're all pretty self-explanatory. So I'm not going to cover them too much in depth. If you've had the chance to read ahead and you want to see a demo of some of these things, just let me know. Or even later in the week, if you're like, hey, I don't know, you know, what this is doing, let me know. More than happy to kick out an additional video. The other thing that you've kind of seen me do before is this data fabrication piece, like where we use union all to kind of build some data here, so on and so forth. So task oriented. Anyway, so that should all be, you know, there's some pretty generic or kind of off the wall circumstances where you might want to use these, where it becomes very helpful. But yeah, they're really handy. So I would recommend you check out these PowerPoint slides. Take a look. We're going to be talking a little bit about them here as well. Have any of you read ahead? And if so, do you have any that are confusing that you maybe want to see an example of?
I'd love to see the one you were just talking about, the data fabrication, the union all. If you could explain that a little bit more in depth, because I thought I understood it, and then I went to do it, and I just didn't obviously get it.
Yeah, for sure. So I'm actually going to use kind of an example, if you will, to kind of showcase this, because where this comes really in handy is when we're fabricating data, which is very applicable to right now, because we should, if you're doing the final project, we're starting our, we should be either starting or into writing some of our SQL for our use cases. So we should have a, we should have like our database, you know, for the most part there. I mean, not saying that we can't go change things once we start putting it in there, because that's kind of the point. But we should start be kind of putting some stuff in there. So just as an example of where data fabrication would be nice, is there was a time someone messaged me for help on their final project where they're kind of making a game. And inside the game, they have a bunch of like different components. And one of those is they have an ecosystem. And, you know, like an ecosystem such as like mountain, swamp, jungle, you know, those kinds of things. And so not necessarily this exactly meets the bill, but, you know, like let's say that we kind of have within the game like certain cells. And so I think it's like a text-based game where you like go from cell to cell, and each cell is kind of like a different thing. Like one might just be a plain old road and the other might be, you know, something else. But let's say we wanted to generate a combination of ecosystem and cells, because we're going to put all this in our database anyways. But we don't really want like a ton of work, right? So that's kind of what we're going to do. So let's say, like, just for some example ecosystems, we have mountain, jungle, plains, swamp, and tundra. Let's say ocean as well. All right, and then for our cell type, let's call it a cell type. We might have a shop, a road, a river, trying to think of anything else. A camp. Let's say a camp. Yeah, so let's just kind of like leave it at that for now. So again, like what we want to do is we want to generate a cell for every possible combination. So we want a mountain shop, a jungle shop, a plain shop, swamp shop, a tundra shop, and an ocean shop. And, you know, if we wrote all these insert statements manually, that would be really kind of a pain. So what we're going to do is we are going to use data fabrication. So in this case, what I'm going to do is I'm going to select mountain as ecosystem. And yeah. Select mountain as an ecosystem. I'm going to union all and then select jungle. Union all. Select plains. Union all. Select swamp. Union all. Select tundra. Go ahead and run this. And now you can see that we have a list of our ecosystems kind of there. Now this is, they don't live anywhere yet because like it's just a select statement, but we're going to get there. So now what I'm going to do to make life easier and just to show you how you can kind of hack this, I'm going to open up Visual Studio Code. And let's create a new file. What I'm going to do is I'm going to use my find and replace here to my advantage. Look for one of those, and I'm going to instead insert a carriage return. All right. And of course, I didn't capitalize these. Let's remedy that before we get too far. And then what I'm going to do, whoops. What happened? No, I do want you to save. I'm lost here. Let's go say, close you. We'll just save you real quick. The desktop, and then we can close it there. Easy enough. All right, so now what we can do is we can use this fancy ability of Visual Studio Code to select multiple things all at once. So I'm going to say select I guess we only need one as cell type. There we go. And now I'm going to look for every carriage return. And instead of inserting carriage return, I'm going to say union all. Carriage return. That again. Union all 2 carriage returns. There we go. You can see if you were doing like a lot of things, that would be really handy. So now what I'm going to do is I'm going to say cross join. And I'm going to use this subquery. And this is where I put my other select statement. So let's go select. Everything from, well, what we need, let's start over. We want to do select ecosystem and cell type from. And now we're going to put our little subquery here. Format this just a little bit. Whoops. call that eco, and then we're going to cross join this with what we're going to call cell type. Now what we can do is run this, and automatically for us, it's generated every possible combination. So we have a mountain camp, a mountain river, a mountain road, and a mountain shop, and so on and so forth down the line. You know, we could multiply this into like 3 if we wanted, so on and so forth. So, you know, it's just really handy to kind of use that to kind of generate some data. So you don't have to write, you know, because like how many records do we have here? 24. That way you don't have to write 24 insert statements, if that makes sense. Because then from now we can, we could use an insert statement. So like if I really quickly wanted to say, create a table, table cell, and it has, really we would usually have like an ecosystem ID and a cell type, but we're just going to put it in there. Ecosystem name. And it is varchar 60 and a cell type, which is a varchar 60. So we can create that table, hopefully. And then we can just go insert into cell. Somewhere I lost my window. Here, there we go. Let's do this again. We're going to create our table, insert into cell. And now let's select everything from cell and see what we get. I'm not sure why that's not showing up there. There we go. There is our cell table. Now, one more concept before we get going, because it's come up a few times, so I wanted to hit it. That's kind of in this same vein. Is a lot of people are building like, you know, product type things or other things, and in many of the cases, like I'll give another example that's kind of in the same game scenario, and a player's inventory. And so like in our inventory in a game, we often have like a bunch of different things, like, and they're all items, but each item might have different attributes. So a weapon might have damage, you know, something like that. A piece of armor might have a armor rating, and like a placement, you know, like doesn't go on your head or, you know, something like that, you know, and so on and so forth. Like in a potion might have a type, you know, is it a magic potion? Is it a mana potion? You know, health potion, whatever. And let's call it strength, you know, some various things. So, you know, and how do we handle that? Well, I think like the way our minds work is we kind of want to like say like, oh, well, I'll have a weapon table. So, you know, create table weapon. And I'll have a armor table, create table armor. And I'll have a potion table, create table potion, because that way you can put, you know, your different attributes underneath it. You know, like potion ID, type, strength, so on and so forth, which is kind of where our minds immediately go. But the thing we got to remember is that because everything kind of has to be connected, and this is where the use cases, the test cases come in, is we have to have a way to query this all, which can be really interesting if we have to write 10 different queries just to get a list of everything in our inventory. So what I would recommend, and this is kind of just like general design concept, is to kind of build an attribute table. They're often called common lookup tables, and common lookup tables are one of those things that if you go to a job interview, if you can demonstrate that you understand, like, oh, this is a time when I would need a common lookup table, it's very, very handy. And the reason we call it common lookup table is because it's not exactly the most tight as far as data design, but the benefit of it is it's very flexible, meaning that it can work for a variety of things. So I'm going to just real quick kind of demo that. And this time, again, just to kind of like show a different take, is I'm actually going to do this all with code versus use the data ERD model maker. So what I'm going to start off with is just create an inventory table. Sorry, I've been typing lowercase because of Postgres. Create table inventory. We're going to have an inventory ID, which is an int, and it's a primary key. We want it to auto increment. Next, I'm going to want, let's just leave it. Let's just leave it simple for now. So let's actually just do that. Let's another thing. So I guess while we're here, I'm sorry, I'm going to be kind of explaining some of our test case stuff along the way. So what I'm going to do is I'm actually going to create a database here real quick. Create database. I'm just going to call game. So database is created, and now I'm going to use game. So I always like to put a use statement at the top, just so that way, you don't build like 100 tables in the wrong database. So let's create the table inventory. And next what I'm going to do is I'm going to create a table called inventory item. Now we're not going to be able to put anything in here yet. In fact, we're not going to be able to build it yet. Because we're going to say an inventory item ID is an int primary key with an auto increment. And then we're going to have a inventory ID to attach it to someone's inventory. And then we're going to have an item ID. And this is why we can't build that yet, because we don't have an item table. So let's go ahead and do that. And then we're going to say, yeah, there we go. All right, so now I'm going to create our item table. Item ID, int, primary key, auto increment. We're going to give it a name, varchar 30, and it's going to be not null. And then we're going to have an item type ID, which is an int, not null. And again, we can't build the item table yet because we got to have item type. So that's why I keep kind of jumping around, because I'm hopefully trying to go like with how brain logic works, which means you often have to backtrack. So create table item type. We're going to have an item type ID. Int primary key auto increment. We're going to have a name. Again, varchar 30, not null. All right, and this is just going to hold like basic things like weapon, armor, and potion. I am going to put a constraint on name, so I'm going to say item type unique one.
You name in both item type and item table, so they'll conflict because they're exact same.
Which ones?
the item type table and the item table both have the name sections that you need to figure out another small change you can make just to make it so they're not identical.
Are you talking this right here?
Right above that.
This?
Yep.
It actually won't be a problem because they're in different tables. It's not a problem.
But when you're trying to reference it, how will it know which one to pick?
That's where the table aliases come in. Because whenever there's two columns with the same name, you have to designate a table qualifier, which I would recommend anyways. And so it'll know like, oh, the name comes from item type versus from item. And we'll actually build like a little quick example of this. You'll actually get to see in action here in just a minute. Let's build this unique constraint on name. So let's build that table. So we have inventory, we have an item type. We have our item table, but we need to give it a constraint. We need to connect these two. So constraint item foreign key 1 is a foreign key on item type ID. And it references item type ID. All right, so there's our item table. So now at this point, we should have inventory, item, and item type. And at this point, we could build a inventory item, which let's go ahead and do that. Well, let me think here for a minute. Yeah, let's go ahead and do it. Yes. Build our constraint though real quick. Constraint, we need to connect this to inventory item. It's foreign key on inventory ID, and it references inventory ID. And then we're also going to do the same thing for and one other thing that I'm going to do, because I'm just trying to piece this together. Let's think. Actually, no, let's leave it just like this for now. If we need to fix it, we can always come back. All right, so now we also have inventory item. So now at this point, we could put items in an inventory, but we wouldn't have very many details about what that item is as far as these attributes. So just to kind of fill in some information real quick, I'm going to say insert into item type. And basically all that's in there is a name. So let's do weapon, armor, and potion. All right, so now we should have our item types, weapon, armor, and potion. And we could build some items and attach them to a specific weapon type. So let's go ahead and insert a couple of these different items. And just I'm going to pause here for a second because these are actually test cases. So what I'm going to do is I'm actually going to label these, right? So I'm going to label this as and what I mean by test cases is it's really just sample data. So this is going to be an insert statement or create. So I'm going to label this like C 1.1 or something, you know, something like that. I'm going to give it a number, some sort of identifier. So let's just do C.1.1. And we'll come back to that why I'm labeling these. Next, we're going to insert into item. We're going to give ourselves a couple of items here. So I'm going to create an item, and I'm going to call it a, oh shoot, what do we want to call it? Does anyone know off the top of their head? Oh, actually, I do know. So faux hammer is one of the swords in the Lord of the Rings. So we're going to go with faux hammer. And its weapon type would be a 1. But again, we're talking about subqueries, so we're going to use one. So I'm going to say select item type ID from item type where name is equal to weapon. There we go. Let's insert a couple other items just since we're here. So now instead of faux hammer, I'm going to say the helm of destruction. And it is a piece of armor. And then the next thing I'm going to put in there is a large, invigorating potion of mana. And it is a potion. All right. We need to specify our inserts here. So we're going to insert name and item type ID. And these are our values. There we go. Let's insert that. And there we go. Let's make sure we got it there. Select everything from item. Oh, something didn't work quite right. Let's make sure. Type where the names are right. I'm not quite sure why it's not showing me what the outcome is. I'm sure there we go. Okay. Oh, data too long for column A. So this is too large of a name. And this is a good example of why we put constraints on things. Because let's say when we're building our user interface, we can only display up to so many characters. In this case, we said 30 characters. Maybe that's too small. I'm not sure. In this case, I'm just going to take off this word. You know, maybe we would want to increase it for real, but for now, I'm just going to do this. Okay, so now we have our items. And again, I'm going to make this a test case. So let's go ahead and call this. And why did I call this C? Oh, for create. So this is another create.1.2. All right. So we have our items. Now we're kind of built to this point where we've tested all the way up to where we are. But the problem is we don't have a way to store information about these different attributes. Like for example, a weapon has a damage attribute, but armor doesn't necessarily have a damage attribute. It has an armor attribute. And we don't want to just like put a million different attributes in our item table and then try to make sense of it on the other end of what we're going to use. So we're going to use what's this lookup table concept, where we're going to actually be able to store a bunch of these attributes and reference them in a way that's actually very efficient and flexible for a lot of different types. So what we're going to do is we're going to add a couple more tables. So we're going to create a table, and we're going to call this table item type. Yeah, let's do item type attribute. Kind of a long name. And just for simplicity's sake, I'm going to say item attribute ID. Actually, I changed my mind. We're just going to call it attribute ID for short. Integer, primary key, auto increments. You'll get used to typing these things quite a bit. We're going to give our attribute a name. So essentially, you know, what kind of a name is it? Those kinds of things. So we're going to give it a name. Varchar, I'm going to learn. We're going to leave this varchar 30, not null. I'm also going to say a data type, which is a varchar 30. And again, not null. And we'll get around to why I'm doing that when we get to the next table. So now what I'm going to do is I'm going to just give this a real quick constraint that I want the name to be unique. For example, I don't want to, oh, and I'm forgetting one crucial element. We need item type ID, which is an int, not null, so we can connect it to item type. Now, I'm going to create a unique constraint, meaning that you know, I don't want a weapon to be able to have 2 damage attributes. We only want 1. So I'm going to create a constraint. I'm going to call it item type attribute unique 1. And it's going to be a unique key on item type ID and name. Because a weapon might have damage, but maybe a potion has damage as well. Like, I don't know. Or maybe there's like an attribute like level that we want all the, you know, these items to have. Like maybe there's a weapon level and an armor level, you know, something like that. So we're going to give that constraint there. And I think that is good for the item type attribute table. So there's that. And next we're going to create the thing that's going to bring it all together. And actually, before we get too crazy, let's create some of our attributes. So I'm going to create another test case. This is C.1.3, and I'm going to say insert into item type attribute item type ID name and data type. All right, then we're going to kick in some values. So for our first one, we want to do weapon. And the beautiful thing is we already have this subquery handy. So we're going to just steal that, put it right there. And then we're going to give this a name. And in this case, I'm going to say damage. Now, most of the time, like with this kind of stuff, you want it to be very programmy. In this case, I'm going to leave all mine lowercase. And, you know, actually, now I'm thinking about it, let's make this a little bit more fancy. So let's, we're going to take this one step further. So I'm going to drop table if exists item type attribute. And recreate it. There we go. All right. So what I did is I added this column called display name. And the reason being is because I want a name that's easily accessible for code people like me. So I don't have to worry about spelling because I don't want to look it up every time. But I also want one that's easy to display for the actual application. So for example, capital D damage. And a damage is going to be just like an integer, like, you know, it gives 1 damage. So I'm just going to say int. And that's kind of just a helper. Now what I'm going to do is I'm going to copy this because we're going to put a couple of these in here. So going off our level, we're going to give weapons level. Again, is an integer. And then we're also going to give it a type. You know, is it a magic staff? Is it a, is it an axe? You know, those kinds of things. And that's going to be a string. And let's do armor next. We're just going to do one example here. armor is going to have an armor rating. Again, an integer, and then we're going to have it also have a level. Right, I'm going to leave, like, I'm going to keep this simple. So I know we talked about a couple other things like placement, but just for the sake of time here. A potion is going to have a type as well. It is a string. All right. So there we go. So let's go ahead, and it looks like I'm missing something here. There's our subquery, there's that. Oh, is that too much? There we go. All right, so let's run this. Got them inserted. And now we can select everything from our item, type, attribute. And here we can see all of our little attributes for all of our different item types. Very cool. Okay, so now we're going to get to the point where we kind of bring this all together, because right now things are kind of, all the pieces are there. It's in a mess. We're going to bring this puzzle together. So the last step we're going to do is we're going to create a table called item meta. And you can kind of call this whatever you want. You can call it like item attribute. Actually, I am going to call it an item attribute, because here we have our item type attribute, which kind of tells us, like, what are the attributes of the item type. But this is actually for an individual item. What are the values that are stored there? So again, I'm going to call this an attribute ID, int. And again, back to that point, you'll notice that we have two attributes IDs, not a problem. Primary key and auto increment. We're going to have an item ID because we want to connect them. It's not null. And then finally, we want to have a way to connect to our attributes. So we're going to have an item type, or really it's just an attribute ID. Type attribute ID is an int, not null. And yes, let's build our foreign key constraints. So item attribute, foreign key 1 is a foreign key on item ID, and it references item ID. We're going to do that one more time. This time on type attribute ID, and it's going to reference item type attribute ID. And then finally, because we don't want a weapon to be able to have 2 damage, attributes. Like once we have our foe hammer, we want to set it to have 1 damage attribute. We don't want it to be able to have 2, because that would just break things. So I'm also going to build a unique constraint on item ID and type attribute ID, meaning that it can't be in there twice. And there we go. So now we have all of our tables created that we need to do it. So let's kind of pull this all together. So I'm going to insert some of our data here, and then we can build a query to kind of bring this all together. So let's do a quick insert into item attribute. And let's start with our item ID and our type attribute ID. And yeah, that's it. Oh, and I forgot one thing. The most important thing in this whole thing is a value. And I'm going to set that to be a varchar 250, which is big, but it's going to be there. And I'm going to let that be nullable. So let me recreate this table. So drop if exists, drop table if exists item attribute. So now that table is gone. Let's recreate it with the new column. We could just add that column later, but there's nothing in it. We're just going to do it the easy way. All right, so now we can get started. So let's do our values. And we want some of our items here. So let's start with faux hammer. So I'm going to build a subquery. Select item ID from item where name is equal to faux hammer. And our item, our type attribute ID, we're going to do another subquery. Wow, what a great example for this week. So item type attribute. Actually, it's just attribute ID. This is why I made those shortcuts. Select attribute ID from item type attribute where name is equal to damage. And this is where I really like to put the code friendly spelling in here, because that way when I'm doing my subqueries, I don't have to worry about spelling as much, like it's all going to be pretty straightforward. And common practice is like, if you need a space, use underscore, those kinds of things. And let's see, we're missing one step here, and that's we want the damage attribute for weapon. So we're going to do kind of two-step thing here. So select the attribute ID. So let's start off by selecting the type of the weapon. So let's build another test case here. This one is a read 1.1. And I'm going to put a little comment here. Gets the item type for a given weapon. All right, so we're going to select for a given item, not just a weapon. Select i.name and type.name from item I, inner join item type T, item type ID is equal to T dot item type ID, where I dot name is equal to faux hammer. All right. So now we have this subquery that returns the name of the weapon and the type. So basically, I'm going to use this same subquery. And not only are we going to get the attribute from the item type attribute, but we're going to get it for the weapon, since we already kind of have the weapon here. Because this will make our life way easier as we're inserting multiple things. So we still want the attribute ID from the item type attribute, which is what we'll call that. So ITA, eventually when we get there. So let's start off by selecting it from item I, inner join, and this is actually where we can just take and copy this right here. And this is where I start to kind of get where, I might want to build out it in a different format. So that's exactly what I'm going to do, is I'm going to format this just a little bit so it's a little bit easier to read. So we got the name of the weapon, but now we want to get everything else. So we're going to get the item the attribute ID from item, and we're going to interjoin that with item type, where we have our name is equal to faux hammer. And that was our previous query. So now what we're going to do is we're just going to add this little piece here. where we interjoin this with item attribute on type dot item type ID is equal to ita dot item type ID, because we want to connect weapon to weapon in the weapon damage. And we can just change this to an and. All right, there we go. Pretty simple. So there is one of our things. So this should insert that weapon with our stuff. So let's go ahead and copy this. So we have faux hammer has damage. Let's also give it a, oh, and I forgot a value, right? Because we have item ID, type, and value. So we need to give it a value. We need to tell it what it actually is worth. So how much damage do we want this to do? Well, let's say it does, I mean, it's Gandalf's sword. It's got to be pretty good. Let's say 240. 240 damage. And that's a varchar column. So I am going to put that in quotes. And the reason we use varchar is because it needs to hold everything, whether it's a number or anything like that. And that's where this little helper column comes in. Not that we're going to use it on our database, but maybe on, maybe you want to do specific logic handling based on the type of attribute it is. So it's kind of this there to future-proof, make things easier on developers. So now let's, so we have our damage. Let's do our level for this item, and it's a level 100. All right, perfect. So there's our that, and then I think we had the Helm of Destruction. Helm of Destruction. And this one, you can see that's a lot easier just to type the name because it's just more friendly to us. We're going to do an armor, and it provides 50 armor. And you can see how you could add like multiple attributes. Like, and this is like really where the design of your game comes in. Because like maybe the Helm of Destruction adds a bonus, and you could kind of like put a bonus in there. And then I think our armor also had a, oh, and we forgot weapon type. Let's do a level here. And oops, it's not what we wanted. We want to keep that Helm of Destruction. The level of this is a level, let's say 15. All right, let's do faux hammer. We want to tell what kind of this is. And I believe the faux hammer is a one-handed sword. So for type, we're going to say one-handed sword. All right, getting there. So now let's do our mana potion, which was called Large Potion of Mana. And we gave it a type, which it should be in the name because it's a mana potion. Mana. All right, let's go ahead and make sure this works. And oh, we broke something. And so this is where that one comment came in of, oh, you have two name columns, and it says, oh, column name in where clause is ambiguous. And you'll notice that these all say names. So basically what we have to do is we just have to tell it what name are we talking about. And in this case, we're talking about the item type attribute. So I'm just going to put ITA dot in front of all these. So that way it knows exactly which name I'm referring to. Whoops. This is actually item.name. So we're going to have two of them. I.name and ITA name. So let's just do the ITA and we'll come back to the I dot. Because this is the name of the item. This is the name of the item type attribute, which we set those nicknames right there. So let's fix these ones. Name, I.name, and I.name. Try again. Select. Oh, and that one we didn't need because they're actually both, they're separate subqueries. Sorry, I for some reason was thinking they were the same for a minute. There we go. So because this is an isolated subquery, not connected to the next subquery, that one's not ambiguous. So there we go. So now let's go ahead and do a select everything from item attribute. And, this doesn't make much sense now, but the nice thing is we have, a bunch of different kind of like attributes here that we can then pull from. And again, we're going to use a subquery for this, or we could do joins. Let's do a join. So another test case. So it's going to be read.1.2. And we're going to say this gets let's say this gets the attributes for a single item. And I'm kind of thinking like, as we look at like a something in a game, like usually like it shows like, the stats on like in a list or whatever. So let's try this out. So we're going to get the I.name as item name. I'm going to get the, let's just start there. I'm going to get the attribute name. So ita.name as attribute. And then we're going to get the item attribute dot value as value. From item I, we're going to interjoin that with item type, kind of like what we did before. IT on I dot item type ID equals IT dot item type ID. Let's actually put that in there. IT.name as type. Then we're going to say interjoin item type attribute ITA on IT.item type ID equal to ITA.item type ID. You get sick of typing that one a bunch. And then finally, our item attribute IA, we do that based on I.item ID is equal to IA.item ID, and where ITA.attribute ID is equal to IA.type attribute ID. Type attribute ID. Let's make sure. Type attribute ID. Yep, perfect. Where I.name is equal to Hammer. So now what we do is we now have a way to show all of our attributes that can then be used in our front end application, to show our different attributes. And, I displayed the name, but really for the attribute, we want that new little fancy column that we had called display name. Let's fix that. There we go. Now it looks pretty. And so now you can see that we have, our item name, the type of weapon it is, its damage is 240, its level is 100, and its type is a one-handed sword. And what's cool is because we have all these different attributes, I'm going to take out this where clause and let's just run it for all of them. And what's cool is now we have a way to fit all of these different attributes inside of a single solution. So we didn't have to build a table for each one of these item types. We actually just had a column called item types, and then we made it so we could attach attributes to those item types, which is pretty cool. Anyways, I'm going to pause for a second. Does anyone have any questions, or is this helpful? Like, is this concept helpful? It's one of those things that I think comes up frequently. So wanted to make sure. It looks like I had a typo on one of these, but whatever. Any questions? Does it make sense to everybody what we just did? That because I'm not seeing a lot of I don't see faces, but a lot of blank faces. Oh, go ahead.
Most of it made sense. There was a few times where I was like, there's so many abbreviations in there that it gets confusing.
Yeah, and that's the problem with aliases. You know, because you kind of got to see it. But let's to make this easier, what I'm going to do now is I'm actually going to forward engineer this database. So let's go to database and let's reverse engineer. And I'm going to, do that connection. Type in my password. We're going to do it for game. All right. So just to kind of like make this hopefully a little easier. Kind of, and well, we never connected it to inventory, but yeah, it doesn't, not too big of a problem. Did I forget to do a connection? It looks like I forgot a connection real quick. So let's go ahead and fix that. It's when I create my item type. Yes, I forgot a constraint. And I know I forgot that constraint because it's not connected. So I'm going to go ahead and create that real quick. Foreign key. And this will actually be, this is actually great. Item type ID to kind of show you what's going to happen here. References, item type ID. All right, so at this point, if I were to try to drop this table, it's going to throw a fit because it says it cannot drop this table because it's referenced by a foreign key constraint, meaning that, hey, something depends on this, so you can't delete it, which is good. You know, that's safety for our database. So this is where I get to where in the announcement I said I was going to show you how to compile your test cases so that it works. And this is a perfect example of why. So what I'm going to do is I'm actually going to create a new file. So I'm going to say, how do I do this? I'm going to say new SQL tab. And what I'm going to do is I'm actually going to kind of copy some of my work over in there. Because, you know, this has kind of been like my running test, if you will. So I kind of want to just have this clean up. So I'm going to start off with all these create tables that I have here. And you'll notice that these are in kind of like the orders we built them, which is just fine. So I'm going to get this table here. Item type attribute. That's an insert. Let's get this table. And finally, I think that's it. Yep. Okay. So now I have all my create table statements in here. Now what I'm going to do is to make it so I can avoid that issue where it's like, oh, I messed up and I need to fix this. I need to drop all my tables in reverse order. So really I need to start with item attribute and go backwards. So drop table if exists. And what I'm going to do is I'm actually going to just copy this 1, 2, 3, 4, 5, 6 times. Oops. 1, 2, 3, 4, 5, 6. So we're going to go in reverse order. So item attribute, item type, attribute, inventory item, item type, and finally inventory. I'm going to put some notes in here. I'm going to say create the schema. We call that cleanup. Now I'm actually going to execute everything. So let's go ahead and run this. And you'll notice that it ran quite a few. So it ran all these. Oh, so it looks like one of them did not drop. Item type attribute reference of foreign key constraint. Item attribute. Which one wouldn't it drop? Let's see. So it dropped item attribute. Okay, so let's try this one more time, make sure it works. There we go. And what's nice is see, I can click this over and over and it's going to basically delete everything and basically clean it up. Now it doesn't have any of the data in there, but that's fine. So what I'm going to do is I'm going to actually save this file. I'm going to go file, save as, save script as, and just on my desktop, I'm going to call this game_schema.sql and save. And what's nice is that way, if I ever just like want to create a duplicate version of my database, it's easy to do so. Like maybe I want to test something without deleting it. And then I'm going to save this file. Well, let's actually run this now that we've created everything. So I can run this. Oh, and I must have forgot to create a table in here. Oh, I didn't cut these. There we go. So let's do that. There we go. And I broke my own rule. Use game. There we go. Go ahead and save that. All right, let's make sure there's no more hidden little create tables in here. So I copied them instead of cutting them. There we go. So let's go ahead and run this. Start to finish. There we go. So what I'm going to do is I'm actually going to restart, delete everything, and recreate everything. So now you can see that with 2 easy steps, I can basically delete everything and recreate it. That way, if I have an issue like, oh, I want to change this column name or whatever, I don't have to worry, especially where we're in development mode. You would never want to do this on production, but because we're in development mode, we can just erase everything and start over. And I'm going to save this file. And I'm going to save this file as game. Test case.sql. Test cases. So I'm going to call that test cases. Now back to our EER diagram. Is there a way to refresh this? I don't think so. So let's go ahead and just restart here. So database, reverse engineer. So you can see this kind of example. All right, so here we are. Let's clean this up just a little bit. So at the top of our stack, we're going to have an inventory. It's an inventory item. It's obviously full of items. Every item has an item type, and attributes are based by the item type, and every item has attributes. So you can kind of see how this is like a big circle, which is perfect. There we go. All right. So this is kind of like a little simple example. And in this case, we have 1, 2, 3, 4, 5, 6 tables. So really, we're already halfway to our final project because we have, I mean, if we had more tables, we could flesh it out, but we have our ERD diagram, which we could save. And we have some test cases. Now, not all of them, but we do have some. So real quick, I know we're a little bit over, but I real quick want to do a quick kind of explanation on why I had you kind of label these test cases, because part of the deliverable is the UI map. So that's kind of what I'm going to cover next. So I'm going to pull this over here and LibreOffice Draw. And you can use whatever tool it is that you want to use, but I'm going to use this one just because it's what I have. And let's pull you. You know, we don't need that necessarily. Let's actually go File, Open, Desktop, and our test cases. We'll just put this in Visual Studio Code for now. All right, so what I'm going to do now is I'm actually going to kind of make an interface for my game. And I'm only going to give kind of like a real basic example of what we, you know, might want to do. So just a couple quick ones. So let's put some, I'm just going to use the pen, and I'm going to apologize in advance for my drawing skills because I'm just using a mouse. So take it easy on me. Anyways, I'm going to pretend that this is actually a mobile app. All right, so here's my little screen. Well, that is just abysmal. Let's do like free form, I guess. Okay, so we're going to pretend that this is a mobile app. I do not know why it's feeling the need to put the little curves in there, but it'll work. Okay, so there's that. And the first thing that we're going to do for our test case, and again, I'm kind of jumping because normally we'd want this to show like the entire flow, like from starting a game and that side of kind of thing. But yeah, so the first thing we're going to do is we are going to, let's draw a shop actually, right? Let's draw a shop. So like if we are in a shop, wow, this is not working the way I want it to. I kind of just like want like Microsoft Paint. Let's see. Tell you what, I've got an idea. I'm just going to delete this. We're going to use Zoom. We're going to add, yeah, let's just use this. All right. Go back to the mouse. You over here. Normally I just do this on like an iPad or, you know, make it fancier for things, but we'll just do this. And actually I'm going to change, we're going to just do this like as if we were managing the game. No, let's stick to our guns here. So here's our phone. Phablet apparently. Yeah, we have our little bar here, and we are in the shop. So we might call this a shop page. And inside the shop page, we have a list of items. That's another great attribute is price, one that I didn't think about when we were doing it. We have a list of attributes. So I'm just going to put name. And it doesn't have to be anything fancy because really this is just like placeholders. So we have name. And then, we can even just do these are going to be attribute 1, attribute 2, yada, yada. And this is going to be ditto across the board all the way down. So we have a little back arrow here. Something like that. So this is just one example of one screen. Now, what I ask, like what I kind of expect out of your diagrams, which is this would work honestly, is really just show like a flow. So like I'm just going to do one example for time's sake, and we'll probably do some more in the future, but just to show the flow of what a user might experience in your app or your project or whatever it is you're building. So in this case, this is just one screen of like maybe 5 or 6 that I've done. And what I'm going to do is, I showed kind of like this user interface that, the user will see, but now I want to kind of attach it to what would happen if they were to buy this. Right. So the first thing that happens when I load this page is I get a list of all the items. So if we come down here to our R.1.2, we get all of our items and our attributes. Right. So the first thing I'm going to do is attach that. So for this one, and let's change the color here. How do we change the color? Right here. So I'm just going to kind of like mark this and say for all of our items, it uses, what is it? R.1.2. R.1.2. That looks like a Z, but you kind of get the point. R.1.2. And that way, when you put together your PDF or whatever it is, your PowerPoint, I would kind of put this in a PDF of all your screens. I can then say like, oh, R.1.2, like, let's just say like test case R.1.2. Then, like, okay, so to get this data to populate this UI, I'll run this query. Let's see. And then the buy button. So we didn't quite get this far. So let's just make one real quick. So I'm going to call this one .1. I think we're at 4. Puts an item in the player inventory, right? So insert into inventory item. Just something simple like that. And just for the sake of doing this, I'm just going to, actually, I think we have it right here. Yeah, that's simple. So if we put the large potion of mana, let's say that they bought that. This is now C.1.4. So I would then say test case C.1.4. Something like that. So that way, like, oh, when they hit the buy button, what happens? well, that runs, and that'll put the item in the player's stuff. Cool. Does that all make sense to everybody?
Yeah, that makes sense to me.
Yep.
Perfect. Perfect. Yeah. So nothing too complicated. You can kind of build the layout however you want. And like I said, as far as like detail, like you don't need to outline the whole app, because I've seen some of your projects and some of them are large. And so you don't need to do all this unless you want to. But like really like just show like one process. Like, so for example, if you're doing a store, a good example is like do a screen that shows them the products. Do another screen that shows them their cart. Do another screen that shows putting a product in your cart, and then do another screen like where you check out. Like, to me, that would be adequate. You know, kind of just to show like the general process. Like you don't have to show everything. But with that, you know, like various things, like for example, in this use case, what I would want to do is show like, okay, I added this to my inventory. Maybe I want to show a screen that shows my inventory. And let's say I want to delete something from my inventory or drop it. Let's say just drop it. You know, I could have a drop button and run a delete statement. You'd want to put that delete statement. That's where that create, read, update, delete comes from. You know, stuff like that. So, you know, back to this, like maybe I want to update the gear that I'm wearing in the game. Or maybe I want to update my player name, you know, those kinds of things. And you can write the statement that'll do it. But anyways, I have carried on for almost an hour and a half now. Sounds like you guys get the gist of this. So I'm going to leave it at that. I'm actually going to take a screenshot really fast before I forget, just in case we want it for later. Make sure I got one saved. There we go. Okay. Perfect. So I'm going to leave it at that. Let me clear all my drawings and you'll be done annotating. All right. Does anyone have any other questions before we kind of end this for tonight? If you get any questions in the future, feel free to reach out. I will send these files out on Teams, just as like, hey, if you're curious and want to see how I did it and deconstruct it or whatever, you can feel free to do so. But does anyone have any last minute questions?
No.
All right, perfect. Well, if something comes up, let me know. Otherwise, have a great week. And yeah, let me know if anything comes up.
Thank you.
Yeah, thank you.
Thank you.